and head over to Helix current. Now let's go set up for Helix current measurement. So here what we've got, we're going to disable our burn-in unit. We're going to take out our measurements. And we're going to take our 1.4 mega ohm load, and we're going to set up a meter on this guy. So we're going to leave ourselves a little space, just because this lug is going to be running from cathode, and this is going to be running from ground. Let's grab our handheld multimeter. And we're going to wire this, the multimeter, to the ground lug of our breakout box. This is earth ground chassis, okay? And the other side of the multimeter, we're going to wire to the bottom of our load. Now they can pick out the load that they need to run the current, or run the current that they want. The Helix will run up to 20 milliamps. So if they need something higher, they'll need to create a lower value load. This one I think runs at around 8 milliamps or so maximum. Let's also wire up our cathode to the top of the load. And we're going to run this cathode at around 12,000 volts. So this will be running at 12,000. This will be at 0 across a 1.4 meg. We can do the math. But I don't want to, because I'm terrible at head math. So let's turn this guy on. We see 0 milliamps right now with it off. First step, we're going to actually calibrate offset like we do all the other currents. First off, let's remove measurement devices from ground. All measurement devices. We can leave the ground wire to the wall in place, but the Ross divider wire, let's get that out of there. Any sort of ground current will count toward this measurement. So let's also remove these jumpers from the breakout box. This should be irrelevant. These are grounded internally. This is for 2-wire Helix measurement. This unit and this procedure does not apply to 2-wire at this moment. So let's head back to the GUI and adjust offset to make sure Helix current is at 0.000. All right, currently we see about 700 nanoamps, and we can adjust that out. Add a couple, like one more 0. And we can get that fairly close to 0. It's to where it's bouncing between negative point whatever to positive point whatever. All right, let's reconnect that load and get it up. Okay, so top side to cathode, bottom side to ground. We're now going to re-enable the supply. It can now be turned on, can be hot. This is dangerous. We're still at 0 milliamps here. Let's disable faults and turn it on. We're starting at 1500 volts cathode. This is the lowest the cathode can run. Bypass heater timer, turn on high voltage. Still no current, and close the cathode switch. Now we see about 1 milliamp, 1.09 on the cathode, 1.05 on the helix. This is uncalibrated. Now what we can start to do, I've got a set of recipes here that will slowly step up this voltage. We also want to take our helix current limit trip level up to maximum. Let's also double check. We need to make sure that our maximum is also at 20 milliamps, same as our scale. We're going to take this up to 20. Recipes always overwrite that, so I'm just going to manually type in 20 after I load the recipe. I double click voltage range 2. This sets it to 3000, and I activate. I can now see 2.1 milliamps. Let's go the next range up. Restore, type in 20, and activate. And I now have 6,000 volts, which is double 4 milliamps. And our last one is at 12,000 volts. I set 20 milliamp current limit and activate. And now I have 8.401 milliamps and 8.658 milliamps on the cathode. Let's also set this to 100, just for the sake of consistency, so that we see on our sample and hold current, the cathode is equal to the average current. So let's head over there and see what the meter says. And we had 8.65, and we see 8.65 milliamps on the cathode, which is exactly correct. As you recall, cathode already reads 8.65 in the GUI, which means it is calibrated. So we've verified that cathode is calibrated. Let's simply take the gain of helix current and match up the reading with cathode current. .660. Enter. And we're calibrated. Let's also test our trip level by setting 9 and 1 volt at a time. We're going to nudge cathode up. We can slowly see helix current increasing. Let's go 10 volts at a time. And we tripped somewhere below 9 milliamps. So the analog trip circuitry is not calibratable, but it is lower than what our calibrated reading reads, which is safe. We can also double check this. If we set 2, we should see 2 milliamps when we boot up at 4 milliamp trip current. So we restart it, TWT, immediate helix fault. There's some noise on the helix when you initially start it up, so it's good to get that out of the way, at least on this setup, especially with this resistive load. So we're going to run it up to 2 milliamps. We're going to set 3 milliamps trip, and we're going to take it 10 volts at a time up. And just keep going. 5, and at 2.26 we tripped with a trip level of 3, which I consider adequate. So we've tested the trip functionality of the helix at multiple trip points. We can now assume that this is calibrated. We care more that this reading is accurate to the meter, as long as the actual current at which it trips does not exceed 3 milliamps or 4 milliamps or whatever the set point is that we've set. And that's how to calibrate helix. So we'll just hit this store calibration table in Flash, and we're done.